Seneca. I'm part of the data science discovery team, and in this video today we are going to be doing a question on binomial distributions and representing them using Python. So let's go ahead and get started. So here I have, suppose you roll an 18-sided die 18 times seeking to roll an odd value, right? So here our kind of notion of getting a success, right, is really rolling that odd value. And remember, there's 18 sides, so about half, like basically half of them will be odd values. So the probability of rolling an odd value is basically going to be 0.5, right? And I can kind of write that down in the comments here. Our probability of success is going to be 9 out of 18, because out of 18 sides, there's 9 odd values, which is going to be 0.5. And now it says, using Python, find the standard deviation of the number of times you will roll an odd value, right? So basically the number of times I will get a success, and assign it to the variable named dice. So the first thing we want to do here is kind of define our distribution, right? And we know that there's this is looking like a binomial distribution, right? Because one, there's binary outcomes here, right? Either we roll an odd value or we roll an even value. That's the binary outcome that we have. Number two, there's independent trials, right? Each die that I roll, each time I roll the die, that's going to be independent of previous times. The number of trials basically is 18, because I want to roll this this die 18 times. And then we have the same probability of success throughout, right? The probability of rolling an odd value will always be 50%. There's no biased or unfair die that we're dealing with here, right? The probability of success will always be the same for each child. So we know that this is going to be a binomial distribution. So I guess I can have D representing a binomial distribution, where our N is going to be 18 trials, because I want to roll this die 18 times. And our probability of success, which is rolling the odd value, is going to be 0.5. So that's our distribution. So now I just want to go ahead and define it in Python. So D equals binom, N equals 18, P equals 0.5. Right, so now that we have our distribution kind of defined here, I'm going to find the standard deviation of the number of times I will roll an odd value, right? So that's just going to be d.std, which is going to represent my standard deviation. And let's wait for this to load, and that's going to be around 2.12. So that represents the standard deviation of this distribution here. And we just need to define it in Python, and then find whatever the question's asking. So I hope this video was helpful. If you have any questions, let me know, and I'll see you next time. Bye.